What we're going to be looking at today is E. E. E is an irrational number, and we can approximate it by this here. 1 plus 1 over 1, plus 1 over 1 times 2, plus 1 over 1 times 2 times 3, going on. And if we approximate this out, it would be the summation of x equals 1 to infinity of 1 plus 1 over x to the x. And as it goes out, we actually get the approximation of 2.71 going on and on and on. It is a non-repeating, non-terminating decimal. And this is what we call the natural base E. Now, E is going to come into play, especially when we start talking about natural logs, natural logarithms, and working with those there. So we'll use E with natural logarithms. So it's kind of nice to know what it is and how it works. Now, E, just like pi, is a number. It's just a number. We use it to represent it. So any questions on this here? So let's simplify each expression. For the first one, we have e to the third times e to the sixth. So how do we simplify this? We would add the exponents together, so we could say e to the 3 plus 6, which is e to the 9th.
So with that, actual number?
Yeah. In the calculator, you can type these in. Let's pull up a calculator. There is. Well, there's two different e's on the calculator. One of them is the one we want, and then there is one that we technically don't want. Second quick. Because the one we don't want is, where is that? Alpha sign. We don't really want this e, because it's defined as 0. It's a variable we can use. But the e that we're looking at would be second ln. And for the one we just have, e to the 9th, is going to be 8,103 and tenths, hundredths, thousands, 10,000, 100,000, 800, or 8.083928. So this here would be e to the 9th. Any questions on this one here? All right, let's look at the next one. 16 e to the 5th divided by 4 e to the 4th. But it would be 4e. Because 16 divided by 4 is 4. E to the 5th divided by e to the 4th. Since we have like bases, we subtract the exponents. So 5 minus 4 is 1. So we could write it as 4e or 4e to the 1st. Either way is the exact same thing. Now, most calculators, if you were to type it in, it's going to want that 1 because it's expecting e to be to a power. Because most of the time, we don't have just e to the 1st. We have e to actual number. Any questions on this here? So let's look at the next one. 3 times e to the negative 4x to the second power. So we're squaring everything, yes? So we're going to square the 3. So we'd have 3 squared. E to the negative 4x. And powers of powers multiply. Well, 3 squared would be 9. E, well, negative 4 times 2 is negative 8x. So we would square the 3, and then we'd multiply 4x, negative 4x by 2, because powers of powers multiply. Any questions on either one of these here? We good with these here so far? Yes? Okay. How about this next one here? E to the 7th times e to the 4th. It would be e to the 11th because we can add those exponents. How about the second one here? 24 divided by 8 is? E to the 3rd, because e to the 8th, so 8 minus 5 is 3. Any questions on any of these here? And last but not least, we have 10e to the negative 3x cubed. Well, that'd be the same as 10 cubed times e to the negative 3x times 3. Well, 10 to the 3rd is 1,000. And then we'd have e to the negative 9x. The other way we could write this is 1,000 over e to the 9x if we want to keep the exponent positive. We can move it from the numerator to the denominator. So any other questions on these here? Okay. That's 64. Let's try this again. So the cubed root of 64e to the 9x. How would we simplify this here? Can I simplify the cubed root of 64? What times itself 3 times is 64? Yes. Now, the way that we can think about this is in different ways, because this works out well. But our real question is e, the cubed root of e to the 9x, and how this works. Now, this is going back to our last chapter where we talked about the nth root of a to the x is equal to a to the what? X over n. So this here would be e to the 9x over 3. Well, 9 divided by 3 is? So, for our original problem here, this would be 4e to the 3x. Any questions on this here? Now, again, I was thinking through this and kind of like, well, does that always work? Well, yes, it actually ends up always working. Because even if we break this up into essentially e to the 9th to the x to the 1/3, there's e to the 9th to the x over 3, but when we multiply it by the 9, we'll still end up getting back to 3x. It'll still end up working out, because no matter how we rewrite these, it works out nicely. Now, we do have to be careful sometimes if we have even roots, but those properties of roots, our rational exponents, do help us out with these here. Any questions on this here? Okay. Now this here is kind of the last thing we're going to talk about with exponential growth and exponential decay. And as we see here, it's going to come in the form of y equals a times e to the rx. It's called a natural base exponential function. Now in both cases with exponential growth and exponential decay, they state that the number in front of our e is going to be positive in both cases. So again, just like we were talking before the lesson, they really don't talk about with having a negative in front. They don't talk about that too often. especially telling it if it's determining whether it's growth or decay. That's not something they really delve into. Now, with this being said, the real difference is our rate. If the rate is greater than 0, it's considered exponential growth. If the rate is less than 0, it's considered exponential decay. And we have our two main graphs here. So here, so y equals, let's just say a is 2, e, and give me an r value. It's positive, 3t. Well, with what we talked about on Monday, it was considered exponential growth if our b, where e is, was greater than 1, yes? What did we say e was? It was 2.7, yes? Is that greater than 1? Well, yeah, so this would be, especially even considering those, would be considered exponential growth. Because our b value is still greater than 1, yes? Now, using the same thing, but we'll switch it and say e to the negative 3t. Well, when we talked about decay, our value b was between 0 and 1, yes? Well, whenever we have a negative exponent, to make it positive, we move it from the numerator to the denominator, yes? So really, this would be the same as having 1 over e to the 3t. We moved it to the bottom of the fraction. Oh, wait a minute, now I changed that value because since 2 is on bottom, it's now less than 1, yes? So this is exponential decay by what we talked about yesterday, or on Monday. And they work. So really, the exponential growth and decay that we had on Monday, y is equal to b to the x is growth. And our exponential decay, y equals, well, 1 over b to the x, because if we're considering b to be whole numbers, is the same as saying b to the negative x. If we're talking about whole number answers and we're not dealing with fractions. Is the same thing, would be exponential decay. So, if we looked at y equals 3e to the x, would this be exponential growth or exponential decay? This would be, the exponent is 1, it is positive. Since it is a positive exponent, it would be growth. So I already have 3e to the x plugged into the calculator for us. So this here would be an exponential growth, so because as we see it increase, as the value of x increases, the function itself increases accordingly. And again, the homework, just like with the one on Monday, will ask you to pick which one of the 4 graphs is correct. Well, we can graph it. E is a little bit harder to work with than the ones we did on Monday because second table, we're always going to have decimal numbers. Because E is irrational, it's a non-repeating, non-terminating decimal, there's nothing that we can multiply it by and get a nice whole number. Even factors of 9 or 10. It's not going to work out nicely. So we can at least get something that looks close to it. Any questions on this here? Okay. How about B? Would it be growth or decay? It would be decay because our exponent is negative. Now if we were to look at the graph of this, we would get this function here, and as we go from left to right, the function is decreasing. So looking at these here from left to right, so number 4, would we consider it growth or decay? It would be growth. How about number 5? And number 6. Any questions on anything we've covered so far? Simplifying E or growth and decay, and kind of figuring out which functions we're working with. So good with this here?